Hello everyone, my name is Vamsi Krishna, Assistant Professor from the Department of Physics, AKNU Rajahmundry. So far we have discussed the construction and working of JFET in mm, the case of VGS is equal to 0 volts and VGS is equal to negative voltages. Okay, so what we have learned in these two cases is in case 1 the main difference between the case 1 and case 2 is we can obtain the saturation condition means id current means with pinch of voltage we can obtain the more earlier in the case 2 than the case 1. Okay, I repeat, we can obtain the saturation current and the pinch of voltage more earlier than in case 1. Okay, will obtain in case 2 than in the case 1. That's the main difference. So in case 1 we have obtained the 0 volts and in case 2 we obtain the negative potentials to the p-type material. So from this the drain characteristics is the drain characteristics means the it's a plot between id versus vds. So we are changing we are increasing the voltages means between the drain and source. So what will be the output of current? Output current is id here. Mm. so so we are taking vgs is equal to 0 at the in the case 1. In case 2 we are decreasing the voltages of between the gate and source terminal means negative, we are giving the negative potential to gate and source terminals. Okay, between the gate and source terminal means we are giving the negative potential to the p-type material. So so we are planning to see that uh, to plot the output current versus input voltages. Input voltages is means VDS. Okay, so when we increasing this VDS, how it will be changing? How it will be changing the output current? How when we increasing the VDS, how will it will affect the output voltage of output current of ID, keeping the VGS is equal to 0 volts and keeping and VGS is equal to minus 1 volt, VGS is equal to minus 2 volt, VGS is equal to minus 3 volt, VGS is equal to minus 4 volt. Okay, so you can know that you know that when we increasing the potential between drain and source, the what will happen, the current will be increases, okay, up to the pinch of voltage. Okay, so after the pinch of voltage is reached means when these two depletion layer is touch each other, what will happen is the you will get the saturation output current id from the device. Okay, so like that if we decrease that vgs is equal to minus 1 watt, what will happen is pinch of voltage will be obtained earlier than in the vgs is equal to 0 volts. So if we decrease decreases the voltage means voltage between gate and source terminals, they will obtain the vgs will be at lower value of vds will obtain the vgs we obtain the vp. Vp means pinch of voltage. At lower values of vds will obtain the vp earlier at negative voltages at negative voltage of vgs means gate to source terminal. Okay. So this active region we call it as ohmic region. This region we call it as saturation region. Sorry, this is ohmic region. This is what we call saturation or active region or pinch off region. Okay, here the VDS is greater than modulus of VP. Okay. So when we increase more and more VDS beyond this pinch of voltage, what will happen is there will be a breakdown in the device. So you will get the maximum means you will get the what we call we will get the infinite mean will you will get the uh, infinite current. So this is happening because the electrons, whatever the electrons in this JFET will gain the more kinetic energy. Okay. On increasing the VDS, the breakdown of the device will be occurred. So electrons in the semiconductor gain more kinetic energy. Therefore, ID will increase drastically. Okay. So in case of N channel, JFET and J, in case of N channel JFET, VGS is equal to is negative, is a controlling voltage. In in case P channel, in P channel JFET, the VGS should be positive. Okay. So if the VP is equal to, means pinch of voltage is equal to minus 4 volts, what will happen was so when VGS and means voltage at the gate and source terminal and pinch of voltage is equal to 0, then what will happen? So imagine the gate voltage at the gate terminal and voltage and pinch of voltage is equal to 0. The potential is equal. So there is no flow of current. So if there is no flow of current, the ID current will be 0. Understood? So there is a potential between drain and source will be 0, equal to 0. So the potential difference across the channel is equal to 0 volts. In that case, also depletion level must touch each other. Okay. This is all about the drain and source drain characteristics. Is a voltage JFET as a voltage controlled resistor. So the ohmic region are also called as voltage control resistance region. In this region, the JFET can be used as variable resistor. Uh, if a resistance is increased or decreased, the changes according with change of VGS. So resistance are decreased or increased depends mainly due to of VGS. Okay, so relation between VGS and resistance of JFET is equal, slope is equal to function of VGS. If VGS is decreases, the more negative slope will be negative. The resistance is equal to 1 by slope. If VGS is decreases, resistance will be increases. Means okay. What I'm trying to say is if if VGS is decreases, so what will happen? The depletion layer will be increases more. Okay. So this device getting the more resistance to flow resist the flow of get more resistive flow of electrons from the drain to source. That's the thing. Okay. Let's see the transfer characteristics. The transfer characteristics is nothing but the plot between ID versus VGS. ID versus VGS. The drain characteristics is about the plot between ID versus VDS, drain to source current. Here transfer characteristics is drain. I mean sorry, uh, gate to source terminal. Okay. So we already discussed this. Discuss this graph, this plot. So initially, when we increasing the VDS, the current means current will ID output current is also increases up to the VP voltage, means pinch off voltage. So when the VP is reached attained, then you will get the maximum current ID. So we have to plot the ID versus VGS in the transfer characteristics. So at 0 VGS, if VGS is equal to 0, if VGS is equal to 0, this then the current will be IDSS. Okay, ID. So if VGS is equal to -1, put -1 here, -2, -2, -3, -3, -4, -4. Okay, so join all the points, you will get the one curve. This curve is called as a transfer characteristics of JFET. So I have completed the topic of JFET. So in next class I will explain the MOSFET, metal oxide semiconductor field effect transistor. Okay, thank you all.